In this video, we're going to look at applying t-interval procedures to paired data. That is sometimes called two-sample data where we have dependent samples. And it turns out that one of the most powerful and informative tests used of statistics is when we looked at paired data. In this type of inference, what we may look at first glance looks like two samples. However, what we really have is not two samples, but rather one sample of ordered pairs, where each ordered pair has a measurement from the first and second measurements, and they're related and dependent on each other. So one of the most common examples of this is before and after data. For example, we might measure the weight of the same subjects before and after a weight loss program. So for each person, we have two weight measurements. In other words, we have an ordered pair of measurements, weight before the program, weight after the program. So what we're typically interested in is not the individual measurements before and after, but rather if the measurements changed and by how much. So what we do in this case is find the differences in measurements. That is, we take the weight after the program minus the weight before the program, or in general, second measurement minus the corresponding first measurement from the same person or from the same pair, from the same subject. So they're paired in some way, so that they're related. So you're doing the difference of the related measurements. So what we end up really is we have a single sample of differences, and then we proceed to perform one sample inferences like t-intervals, or later we'll get to t-test, for example, or z-interval or z-test on this data set of differences. So let's look at an example, and let's review here again the big thing. Paired data example, what we're doing is for paired data, we find the set of differences by taking final measurements minus the initial measurement and proceed using one sample inference methods on this sample of differences. So it's really a one sample test. Okay, so here's an example. A group of people entered a weight loss program. On the first day of the program, they were weighed. After completing 6 weeks of the program, they were weighed again. Their measurements are given below. So here, if you look at the sample, has 9 subjects. The first subject weighed 180, it didn't say here, but let's say pounds on the first measurement, 175 pounds on their second measurement. The second subject weighed 225 on the first day of the program, went down to 200 on the on the 6th week later, and so forth. And you can see the data there for all of them. So what we want to do is construct a 90% confidence interval for the mean amount of weight change. We're going to assume that the distribution of weight losses is approximately normal, and does it appear that the weight loss program is effective, which is one of the things that we're going to be most interested in. Okay, so what we do first is we compute the differences. We take the weight at 6 weeks minus the initial weight at the beginning. And we see that that should say -5 for that first one. So we see that the first subject lost 5 pounds. So negatives mean that the weight went down. And we see, I guess, subject 4 has a positive there. So that subject 4 went up 5 pounds and so forth. The rest of them seem to have lost at least some. Now, these were easy enough to just do by hand, do in my head and write them down. But one of the things that we might want to do if we have a larger data set or just the numbers are more complicated, it might be nice to put these in the calculator. And so one way we can do this is to enter the first initial weight in one list, let's say in the computer or calculator, say in list 1 in the calculator, TI-84. List 2 would be the second one, and then let list 3 be the difference. And you can ask the calculator compute the differences. Or you could do the same thing in columns of a spreadsheet, like say in Excel or say in a TI Nspire. So I'm going to show you with the TI-84 and a TI Nspire as examples. So here's the TI-84. So what we can do is hit Stat, Edit, put the cursor on the L1 right here, push clear, and then enter, and it will clear out this list. Do the same thing for list 2 and 3 so that they start clear like list 3 is here. Then type in the data initial one in order for the first one. And whatever order we put that in, we have to make sure when we type in the weight at 6 weeks for the second column, the second list, that it's in the same order so that the first one in each list corresponds to the same subject. Second one in each list corresponds to the second subject, and so forth. Then what you do is you put your cursor on L3 and type in L2 minus L1. L2 is second 2, then subtract, and then second 1 is L1. Hit enter, and it will automatically figure out the differences. Now let me remind you that the TI-84, this is not a true spreadsheet. So if you go when you put L2 minus L1 and L3, it'll take all the corresponding things in L2 minus the things in L1, but it'll be just what were there when you did it. So if I were to go back now and change this, say I had a typo and I realized, oh, this 180 needs to be, maybe 190, I could go back and change that, but it would not change the first entry here in L3. You'd need to go back and recompute L3, or at least the changed parts of L3 to do that. Whereas you'll see in a minute on in Excel or in the Inspire, which we'll see in a minute, that's dynamic, so that if you change a number there, it'll change on the spreadsheet. So anyway, we've got our data in L3, and we proceed using a one-sample t-test on L3. So we'll come back to the test in a minute. Let me show you how to do the data on the Inspire. So the Inspire, we make sure that we have a spreadsheet here, and on the spreadsheet we can actually name the columns. So I actually, in this cell right here, way up the top, on column A, I typed before, and B, I typed after. Type in your data there in that column, starting with cell A1 and all these cells down here. Type in that first row of data. In the same order, type in the after data there. And then for the difference, I went ahead and labeled it as difference. And then this has an then in this box right here, the second one from the top in column C, I just typed in B minus A. And what that did is it takes column B minus column A and puts those all the way down the column here, and that does exactly what we want it to do. Okay? So on the TI-84, our differences are now in L3. On the Inspire, our differences are in a column C, but we've named it differences, or difference. Now, the next thing to do is decide what kind of inference we want to do. In this case, we're doing a confidence interval for a mean. Okay, and we assume that the distribution of differences is approximately normal and the standard deviations of all weight differences is unknown. So these are exactly the conditions we need to our t-interval. And here we're going to use the built-in t-interval apps to work this out so that, the calculator is going to actually do almost all the grunt work for us, all of the calculations. So we basically just have to write down the answer and interpret it. So on the TI-84, we hit Stat, left arrow to Test, choose number 8, t-interval, choose Data, make sure this says L3 because that's where our data is, because we're wanting the data on the differences, which are in L3. Our confidence level is 90%, so that's 0.9. Hit Calculate, and there's the confidence interval. There's the sample mean, sample standard deviation, and sample size. Negatives mean, of course, that they lost weight. Okay, so on the Inspire, you hit Menu, number 6. It's covered up here, but it's Statistics. Down here, and I think it's 6 again, Confidence Intervals, and then number 2, T-interval. And so you can do that. You could hit Menu 662. Or use the arrow keys to click on it. And then, actually the next screen I didn't show you here, but it comes up and you select either data or statistics. And this one we're doing from a data. So you select data. Then here we select, we fill in the list. We click on the arrow here and it's going to come up and say before, after, and difference. So we're going to choose difference there. Frequency list is still 1. And then confidence level is 0.9. And then click OK, and then here's the confidence interval. There's the lower limit, there's the upper limit, there's the X bar, there's the margin of error, degrees of freedom is 8, just because that's 1 smaller than the sample size of n, and there's the sample standard deviation. So most of this is the same as this. Over here shows us a couple more digits, and it does it does tell us degrees of freedom and margin of error, which this does not have over here. And it does, both of them tell us that we were using a t-interval there and there. Okay, so how do we look at that? If you wrote those numbers down or we're looking at them, they were, well, I'm going to round them off a little bit here so we can maybe make our conclusions. So we note that the mean weight loss of the people in the sample was 17.89 pounds. The 90% confidence interval for the mean weight change for all people using the programs is negative 27.5 to negative 8.3. I rounded off a little bit there. Since the interval is completely in the negatives, we can conclude that there is evidence to support the conclusion that the program is effective in helping reduce weight. We're 90% sure that the average weight loss is somewhere between 8.3 pounds and 27.5 pounds. Now, let me put a couple of cautions here on this and make sure we understand what we're doing when we're interpreting this. So note that as with all t or z intervals, the conclusion is about the average weight lost due to the program. In other words, it's an interval for the average weight loss. It does not make conclusions about individual weight loss. So notice that even in this sample, some individuals lost much more than the sample mean of 17.9 pounds, and some even beyond the lower end of the confidence interval, 27.5 pounds. So I think, well, there's somebody there that lost 40 pounds. So well beyond the 27.5 pounds, well beyond the 17.9 pounds. Okay. On the other hand, we have some individuals on the other end. We even had a couple of individuals there that actually, or at least one individual there that actually gained weight. So be sure that you understand that a confidence interval is for the average of all people that might use this program, okay? And it is not about what an individual might or might not do, okay? Now, the other thing is we always need to be cautious about concluding unequivocally that the changes are due to the program, because there could be some hidden variables. Maybe there's something else besides this program that is causing them to lose weight. However, since the data is from two measurements with the same subjects, the before and after data, we can be reasonably sure that the changes are due to the program, especially if we're reasonably sure that there are no other hidden factors that we know about. So anytime we're doing any kind of research like this, there's always some danger that there's some other lurking variable out there, hidden variable that's causing what's happening, and it's not what we think it is. But nevertheless, if it seems reasonable that this is it, since we are using the before and after data, that does control a lot for some of the things. Whereas if we just sort of randomly select some people before and then randomly select maybe some different people after and looked at their weight, then of course that wouldn't necessarily tell us as much, because we might have selected people of different weights to begin with. There could be all kinds of different factors there. But if we make sure it's the same person, a lot of those factors are controlled for. And that's why this is such a powerful thing to be able to look at before and after data. Before I go on, let me just quickly actually show you this on the calculator. Okay, so let me just show you pushing the buttons for just a minute. So if I go to Stat and Edit, this is not the same data, so I'm going to go Clear, Enter. Go to L2, Clear, Enter, and L1, Clear, and Enter. So I'm going to go through the whole process real quickly as quickly as I can. 180, 225, 340, 275, 280, 290, 295, 300, and 200. That's the before data. Corresponding after data, 175, 200, 300, 280, 270, 260, 270 again, and 199. Okay. Oops, I'm off one. Where am I off? Oh, it's another 270. 270 here, and then 199. All right, so definitely you need to have the same amount of data in both rows there, both columns. So go to L3, then you do second, L2, minus second, L1, enter, and it finds their differences. So our differences are in L3. Quit, hit stat, left arrow to test, and it's actually number, if you don't remember, arrow down until you find it, but it's number 8, so I can either move up to here, hit enter, or just type in number 8 if I remember which one it is. I can go from statistics and actually enter in the X bar and S if I've already figured them out in the N, or if I have the data like I have, I'm going to go from data. The data is in L3, so second 3 is L3. Confidence level is 90, and calculate, and that's what we got before. Okay. On the Inspire, okay, then you go to make sure you have a spreadsheet. If you don't have one, hit on. Make sure you click on this one right here. That adds a spreadsheet. Okay, go up here and I'm going to give it a name. Okay, and so forth. So let me. I think I already have some of this in. Maybe. Well, I don't know if this is the same data. Okay, so let's go over here, and I'm going to. I want that before, after, and difference here, and I'm just going to highlight all this and clear it out. Okay, and again, I'll type the data in. Okay, I'll pause the video while I'm typing. Alright, I've just about got all the data in here. Typing in my last one now, 199, enter. So you just type the data in and enter. Notice that when I put the cursor on the thing up here, I can name it. This time I named it after. And so you just type those things in there. So you can type a name in. Here, up here, I typed in the name difference. And to get the differences, this is column B and this is column A. I just do down here B minus A. And now I get the differences in column C, and they also have the labeled differences. Now go back to a calculator screen. Here's a calculator screen. And so we go to menu, number 6, statistics, number 6, confidence intervals, number 2, t-interval. It is from data, so I have a choice of data or statistics here. We're going to go with data. Okay. Our list that we're going to use, see there they are, I've named them, difference. And the 0.90, 90%. Okay. And there it is. There's the confidence interval. There's the lower, upper. There's X bar, same as I had over here, lower and upper X bar. Lot more digits over here, but it's the same thing. And there's the sample size 9, and it tells us a couple other things if we need them. So there you could actually see me do it on the calculators. Okay. So as with many things in this course, a lot of the things that are important are being sure that we know how to use our calculators to compute the things that we need. So Let's let you do an example now, an exercise, and see if you can do this one on your own now that you've seen how this works. So in this example or this exercise, a group of factory workers are measured to see their total daily production levels and the number of products they can assemble in a day. So a change in production techniques is implemented in an effort to improve production levels. After receiving some training on the new techniques and practicing them for 1 week, the same workers are then tested again. Construct a 92% confidence interval for the change in production level. Did the program help? Assume that the distribution of changes is approximately normal. And there's the data. So, time for you to do this on your own. So you're going to use your calculators, work out the confidence interval here, and then make your conclusions and interpretations. When you think you got it all worked out, come back to the video and then check your answers with this. So press pause now. Okay, so hopefully you've worked this out. On the left, you see the screens on a TI-84. On the right, you see it in on a TI Nspire. Of course, you could do the same thing in Excel if you know how to use that for it, or a statistical program of some kind. You have methods of doing this in any of those things. So in this case, note that all the conditions for a t-interval are met. What are they? We're measuring an interval, a confidence interval for the mean of the increases. Okay, at least they hope it's going to be increases and not decreases. The mean changes in daily production, and we're assuming that those distribution of changes is approximately normal. That's questionable whether that's actually true or not for this data. But if that was but we need that assumption to use the t-interval with a sample of this small of a size. So that would be, in reality, that would be something you'd have to actually check. But we made that assumption here, so we can skip that check. And then let's see, the population standard deviation is not known, so it's not a z-interval, it's a t-interval. Okay, and so here we go. Put your data in before the pretest in L1, the post-test in L2, the differences then in L3 like we did L2 minus L1. There they are. Do a t-interval using data with L3. This is a 92% confidence level, and out pops the confidence interval there. Okay, same thing for the TI Nspire. Again, I used before, after, and before I did these, by the way, I made sure I cleared out L1 and L2 and L3 over here on the 84. And if I use the same spreadsheet and same names, I need to be sure I clear out these before I start putting in new data. Put in this new data in column 1 in the before column. The after column is this, and then the difference I just did B minus A in this cell right here, and boom, all of them showed up. So there's all the differences, which I've also recorded up here. And then I do menu, statistics, confidence intervals, t-interval. So that's menu 662, and then they'll then choose data, and then difference here, and 0.92 here, 1 there. Okay, and then there's the confidence interval. There's the lower and upper limits right there. So, what's the conclusion? We determined that the mean increase in daily production of this sample is from the sample is 25.5 items per day for that specific sample, and we're 92% confident that the overall mean increase in daily production from everybody is in the interval from about 18 products per day to about 33 products per day. And since this interval is completely in the positives, zero's not in there, and it's completely in the positives, there is sufficient evidence to suggest that the methods were effective in boosting the average production level. On average, from what? Well, at least 18 to 33. At least we're 92% confident that that's how much it was increased. Okay, so this is once again the technique that we use for paired data or two dependent samples. In the next video, we'll see how we can do things, how we have to modify this slightly if we actually do have two samples, two independent samples. So the paired data really is not two samples, it's really one sample of changes, right? And then and you treat it exactly like a one sample test. And we'll see how to handle the two sample test in the next video.